All right, let's dive into something you might not think about every day, but it's pretty important stuff. Manganese.
Manganese.
Yeah, we're taking a deep dive into manganese today. Got some really cool research to dig into.
Okay, I like it.
So we've got excerpts from the Royal Society of Chemistry, some stuff from Wikipedia, should be interesting.
Sounds good.
So picture this. You're in France, you're checking out the Lascaux Caves, those 30,000-year-old paintings.
Oh, wow. Yeah.
Pretty amazing, right? Those ancient artists, they used manganese-based pigments to create those works of art.
Really? I did not know that. Wow, so manganese has been around, or humans have known about it, for a long time.
Right. Way before they even knew it was an element. And get this, today, we're using that same element to make steel.
Oh, wow, that's a big jump. From cave paintings to, like, skyscrapers.
Let's talk about a glow-up. Skyscrapers, bridges, infrastructure, it all depends on manganese. Okay, ready for another layer to this?
Always.
So we know manganese is found in the Earth's crust, right?
Right.
Well, it's also hanging out on the ocean floor.
Really?
Yeah, in these things called manganese nodules. Trillions of tons of them.
Trillions.
Yeah.
Trillions of tons. That's incredible. How does it even, I mean...
Right, and here's the thing about those nodules. They're not just sitting still. Tiny little deep-sea creatures are constantly moving them.
So they don't get buried, like in the sediment. That's pretty cool, I mean.
It's like a dance floor down there.
It is.
But this is what I love about manganese. It's not just about the planet and the oceans.
Hey.
It's in us. We need it to survive. All living things do.
Oh, yeah. I mean, plants, right? Photosynthesis.
Exactly. Plants need it for photosynthesis to make their food, to give us oxygen.
It's essential.
And humans and animals, we need it for a whole bunch of different things. Bodily functions, the whole 9 yards.
Wow. So from the ocean floor to, well, to us.
Yeah.
To life. That's
I
amazing.
know, it's pretty mind-blowing when you think about it. Okay, so it's everywhere, right? But there's a twist. Manganese is kind of a shapeshifter, chemically speaking.
Okay.
It's got these multiple oxidation states,
Sure.
meaning it can change, it can take on different forms, and those forms, they have totally different properties. Like, it's not just manganese, it's manganese with different personality.
Oh, interesting. I see. Yeah, like a chemical chameleon.
Exactly. And this is where it gets a little messy because for a long time, people were mixing up manganese with magnesium.
Oh, yeah. I read a little bit about that. Weren't they both found in the same region, like in Greece or something?
Yeah, you got it. Magnesia, they called it.
Right, magnesia.
Both elements found in the same ores from that region, and I guess that caused some serious confusion.
I can imagine, yeah.
So how did they finally figure out that manganese was its own thing?
It's a good question, yeah. How did they figure that out?
It was like a whole chemical detective story. Scientists, they started noticing these really subtle differences in how these magnesias behaved, like their color, for instance.
Okay, so what, like different colors for different elements?
Exactly. Manganese dioxide, that was known as magnesia nigra, the black ore. But then you've got magnesium oxide, that was magnesia alba, the white ore. So they knew there was something going on, right? But it wasn't until like the late 1700s that Swedish chemists finally isolated manganese.
Oh, wow. So it took them that long to be like, okay, this is different.
Yeah. It's amazing, right? Like today it seems so basic. Like, of course, they're different elements, but back then it was a huge breakthrough.
Absolutely. And the name, too, manganese, that had to go through some changes, right? Like just figuring out what to even call this new element.
Oh, for sure. It's a whole other story in itself how they landed on that name.
Fascinating.
So we've got this ancient element, crucial for life as we know it, shaping civilization. But what does it actually do? I mean, besides the cave paintings and the steel.
Right. What's its claim to fame?
Fill me in.
Well, some historians believe, and it's still up for debate, but some believe manganese might have actually been used to make Spartan swords stronger.
Whoa, really? Spartan swords? That's intense.
It's a theory, but a pretty cool one. What we do know is that it's amazing at decolorizing glass.
Really?
Yeah, and it's a key ingredient in batteries, which is huge these days.
Speaking of batteries, doesn't manganese have like a bit of a controversial side when it's added to gasoline?
It does, yeah. MMT, it's called. They add it to gasoline to make it burn better, but there's this whole debate about whether it can damage engines.
Right, I'd heard about that. So it's kind of a double-edged sword then, helpful in some ways, maybe problematic in others.
Exactly. And that actually brings us to how manganese can affect us, humans.
Right, because we need it, but like you said, too much of a good thing. We were talking about overexposure earlier.
Right, and that can lead to some serious health issues, particularly a neurological disorder called manganism.
And that's where things get really interesting. But first, let's take a minute to recap.
Sounds good.
We've covered a lot of ground here. From ancient cave art to the ocean floor to the air we breathe, it's clear that manganese is everywhere.
And in us.
Yeah.
Don't forget, it's in us.
That's right. It's essential for life as we know it. But we've only just scratched the surface. So before we took that little detour, we were talking about how too much manganese can actually be bad for us. Like, it can even lead to this neurological disorder called manganism, right?
Right. And what's interesting, I guess you could say even a little scary, is that manganism, it often looks like other neurological conditions, especially Parkinson's disease.
Oh, really? So it's hard to diagnose.
Yeah, it can be tricky. They share some of the same outward symptoms, things like tremors, slow movements, problems with balance. But underneath, the causes are different.
Okay, so like with Parkinson's, that's the one where it's like a loss of dopamine, those brain cells, right?
Yeah.
What about manganism? What causes that?
So with manganism, it's not about dopamine. It's more about damage to other parts of the brain, especially an area called the basal ganglia.
Basal ganglia. What's so important about the basal ganglia?
Well, it's involved in a lot of things, like motor control, obviously, but also learning, even emotional responses, decision-making, all sorts of stuff.
Wow, so damage there would be pretty serious.
Exactly. It can really impact someone's life in a big way.
So if the causes are different between manganism and Parkinson's, I'm guessing the treatments are different too.
You got it. Manganism doesn't really respond to the treatments they usually use for Parkinson's. That's why figuring out what someone actually has,
Yeah.
the diagnosis, it's really important. And of course, preventing overexposure to manganese in the first place, that's key.
Makes sense. So how do people even get exposed to that much manganese? I mean, is it just people who work in certain jobs?
Well, that's definitely a big concern, occupational exposure. People in mining, welding, anything with steel production. But it's not the only way people can be exposed to high levels of manganese.
No, it's in other places too.
It can be, yeah. For example, a lot of people don't realize this, but it can be in drinking water.
Oh, wow, really?
Yeah, in some places, the groundwater naturally has more manganese in it, and if it's not treated properly, it can be a problem.
You're kidding. So you could, like, turn on your tap and be exposed. What about showering? Does that matter?
It can, actually. Studies have shown that just inhaling the vapor from a hot shower, if your water has a lot of manganese, it can be a significant source of exposure.
This is blowing my mind. Something we do every day to be clean. And it could be, I don't know, kind of freaking me out a little.
It's understandable to be concerned.
It makes you wonder about your water, right?
For sure. And that's why awareness is so important. Knowing where your water comes from, getting it tested, those things are a good place to start.
What about filters? Do those help?
Yes, some types of filters, like reverse osmosis, they can remove manganese from your drinking water. Showering is a little trickier.
Because you can't exactly filter the air, can you?
Right. Good ventilation is key in that case. Making sure your bathroom is well ventilated can make a difference. And hey, if you're worried, maybe keep the shower shorter,
Right, right. Okay, so that's for, like, high levels of exposure. But what about long term? Like, even if it's low levels, but just over time? Is there some kind of threshold? Or is any amount of manganese building up in our brains bad?
That is the million-dollar question, and I wish I had a simple answer for
Yeah.
you, but it's something scientists are still trying to figure out. There's just a lot we don't know about the long-term effects of lower-level manganese exposure.
So it's kind of a waiting game then.
In a way, yeah.
Yeah.
But in the meantime, it makes sense to be aware and take precautions, right? Like, better safe than sorry,
Yeah.
especially when it comes to our brains.
Absolutely. You know, before we went down this slightly worrying path, we were talking about something much more positive, manganese's role in photosynthesis.
Oh, yeah, absolutely. That's fascinating stuff.
You talked about it being essential, but I kind of glossed over it. Can you remind me, like, break it down? How is manganese involved in photosynthesis?
Sure. So basically, manganese is a key part of what's called the oxygen evolving complex in plants.
Okay. The oxygen evolving complex.
Yeah.
Get you.
Right. But in simple terms, this complex is what splits water molecules and releases oxygen into the atmosphere.
Wait a minute. Photosynthesis, the thing that gives us the air we breathe? You're telling me manganese is essential for that.
That's exactly what I'm saying.
Yeah.
No manganese, no photosynthesis as we know it, and no oxygen-rich atmosphere to support life.
Mind officially blown. We started with cave paintings, and now we're talking about breathing. Manganese, man. This element is everywhere. And speaking of which, there was one more thing in your research notes, something about artificial photosynthesis.
Ah, yes. Now that is a topic for another deep dive.
So before we wrap things up with this manganese deep dive,
Right.
we got to circle back to this whole artificial photosynthesis thing.
Yeah, it's pretty wild.
We were just talking about how manganese is essential for, regular photosynthesis.
Right, the kind that keeps us alive.
Exactly. The air we breathe, the whole shebang. And now you're saying we might be able to, recreate that process.
Well, that's the goal.
Artificially.
Yeah.
Using, what, the same element?
Yep, manganese is the key player here.
Okay, color me intrigued, but also a little lost. How would that even work?
Well, the basic idea is to create a system, an artificial one,
Okay.
that can do what plants do.
So, are we talking, giant artificial trees or something?
Uh-huh, not quite. Though I like where your head's at.
Okay, good.
It's more about, designing these systems, often at a much smaller scale,
Got it.
that use manganese or manganese-based compounds to capture sunlight.
Just like a plant.
Exactly. And then use that energy to split water molecules.
Okay, and then what? What happens then?
Well, if we can make it work efficiently,
Right.
we can have a clean, sustainable way to make energy.
Really? Like what? Like hydrogen fuel or...
Hydrogen fuel, potentially, or even directly generate electricity.
No way. All powered by sunlight. That's huge.
That's the dream.
It sounds almost too good to be true.
It might be.
Is it actually doable? I mean, are there big challenges with this?
Oh, tons. Artificial photosynthesis, it's incredibly complex. I mean, one of the biggest hurdles is just finding the right materials.
Materials.
Yeah, you need stuff that can absorb sunlight really well.
Okay.
But then they also have to be tough enough to survive that water splitting reaction we talked about.
Right, and not fall apart after 5 minutes.
Exactly. Durability is key.
So it's not as simple as I don't know, mixing some manganese with water and leaving it out in the sun.
I wish. It takes some serious brain power, like chemistry, materials, science, engineering, you name it.
Okay, so big, complicated science project, but
Yeah.
if they can figure it out, that's a game changer, right?
Absolutely. Clean energy is, well, it's everything, isn't it? And this could be a big part of the solution.
It's definitely something to keep an eye on. Well, from ancient cave paintings to the future of clean energy,
It's been quite a journey.
manganese has definitely surprised me.
Me too.
It just goes to show there's so much out there, even the elements we think are boring, they're full of surprises.
For sure. And it makes you think, right, what else is out there waiting to be discovered?
Exactly. Who knows what amazing things we might find next? But sadly, that's all the time we have for today's deep dive.
It's been fun.
Always a pleasure chatting with you. And to all our listeners out there, thanks for joining us on this journey into the world of manganese. We hope you learned something new today. Keep those brains buzzing, and we'll catch you next time. This is The Deep Dive, signing off.